All right, so next up, we're going to start talking about the electrons and their orbitals. And if you're wondering why we're so interested in electrons, it's because in chemistry, it's the electrons that are actually going to do all of the actions. Right, so we previously stated that each electron well, we didn't say this before. So we're going to say that each electron has a unique set of 4 quantum numbers. And we could think of this as their address, except in our case, our electrons, no 2 electrons are going to have the same address. So maybe includes like your room number or your bed number or something like that. These quantum numbers are going to be N, L, M sub L, and M sub S. And they're each going to tell us something about either the electron or the electron's orbital. So we'll start off with N. N is the principal quantum number. And what it tells us is the overall size and energy of the orbital. So we start off with n equaling 1. So n is not allowed to equal 0. So n can equal 1, 2, 3, so on and so forth. And then as n increases, the gap between n's decreases. So for example, if n equals 1 is all the way down here, n equals 2 we could put up here, n equals 3, the gap between 2 and 3 will be smaller than what was between 1 and 2, and then so on and so forth. So it tells us the overall size and energy of the orbital. So for something like an n equals 1 shell, it's going to be relatively small. Something from like an n equals 2 is going to be relatively bigger. And so here's just kind of a nicer picture of that. Here we have the 1s, 2s, and 3s orbital. Don't worry about the s part. We'll learn about that for a second. But we can see that the 1, 2, and the 3 represent the n number. So we can see as we grow bigger, or as n increases, we grow bigger and bigger. And then we also have what are known as nodes. So for example, n equals 1, we have no node here. So we just have one sphere. For n equals 2, we have a node, which is a 0 probability chance of finding the electron there. So you can see we've got this big outer sphere and then a little mini sphere inside of it. And in between, there's a node. And same thing with the 3s. Now we've got kind of 3 onion layers. The overall thing that we want to know is, though, as n increases, the size of the orbital increases. Now, remember we said that all of quantum mechanics, essentially, or from our version of quantum mechanics, is all related to the periodic table. So how do we translate this n value to our periodic table? Well, it's just the row that it's in. So for example, everything in the first row will be n equals 1. Everything in the second row will be n equals 2. Everything in the third row will be n equals 3. And then so on and so forth.